I'm Simon Didet, and this is my project for the CSSE120 robot. Uh, the theme is fitness, so it's like the robot's working out at a gym, trying to get stronger than all the other robots. He's seen some of his competition, so he's going to do things like attend spin class, drink water to regain energy, and lift weights. So if I run it on the laptop, it's already started running on the robot. This is the GUI. It starts out at 8 out of its 10 max energy. So let's start off by having it spin 4 times. So this uses the wheel encoders, and it implements the drive system library. And once it's been converted to degrees, so once it does 4 full rotations, it will stop spinning. And the 4th is coming up. And let's say we want to do 5 now. We only have 4 energy left. So if I try to do 5, it'll tell us that we don't have enough energy and we need to drink water. So if we try to drink water, we'll say we're on black instead of blue. It's detecting this ground here as black. And the blue represents the water station. So if we do teleoperation, you can see it can turn to the left and right, it can move backwards and forwards. So if you move over to the blue, right when the color sensor's on the blue, you can click drink water. And now its energy is back up to 10 out of 10. And now we can start lifting the weight. So first I press locate weight. So it turns left because it sees with the camera that the weight is over to the left. So it turns left first. And then with the proximity sensor, it detects how many inches away it was. There it went a bit too far because the proximity sensor isn't perfect, but it got really close. And the red ball was added on top of the weight to make it easier to see with the camera. So now I'll do, say, 3 repetitions of lifting the weight. And send that. So just like anyone at the gym, we'll lift it up completely. 1 time. In a second. And this is using the touch sensor that is already implemented in the arm and claw. When it reaches the fullest height, it stops and lowers the weight again. And it's done that 3 times, and if you look back at the GUI, the energy is at 7 out of 10 now. So going over the rubric, the theme was the robot at the gym, working out, fitness. The GUI was already shown. It has a few buttons, entry boxes, and labels. It can be teleoperated with the keys. You can look again. Oh, well, it's not on now. It does move like spinning and use its arm and claw like to lift weights, and those are very relevant to the theme, I feel. And it can react to its environment by looking at the color to see if it can drink water, and by detecting the weight and sensing how far away it is and moving to it. The code does use things in the libs folder as well. You can look at the rubric as well. As it, like for example, the drive system was part of the libs, as well as arm and claw, color sensor, all different parts of libs. The code was documented, and you'll see that when it's committed and pushed, like if we go to a couple of the functions, I added some doc strings before them. And I did commit and push even small things pretty regularly, just to make sure it would always be working and I wouldn't lose any progress. For the advanced part, the robot doesn't send a whole lot to the laptop, but it does, for example, send the color back. The function was designed to send the color back to the laptop because the energy is stored on the laptop. So it sends the color back to the laptop, and if it's blue, it can drink the water and actually gain energy. The GUI, it doesn't necessarily have anything beyond labels, entry boxes, and buttons, but the fact that the energy can be updated without even opening a new window, I feel is relatively more advanced, but this may not be completely fulfilled. The sensors, it uses wheel encoders and touch sensor, and it also uses arm and claw, well, not arm and claw, that's part of the touch sensor. It also uses the color sensor, the camera, and the proximity sensor. And I would say it is complex in that, especially the code for locating the weight is rather complex, as first it has to detect where the weight is, it has to find its x coordinate, it has to turn to its location, then get the distance from it, and then move that distance, which altogether can be pretty complex and will not work all the time. And finally, I've kept most methods pretty short, and I implemented one at a time to use functional decomposition. And none are more than 15 lines long. So overall, I feel like I may deserve a low A or a high B on the project. And yeah, this is the project, the robot at the gym.